Hello everyone, welcome to IMS Gate Academy. I am Atul Negi, your faculty at IMS Gate Academy. In this last 4 months of the GATE exam preparation, we need to focus on the revision and the practice part. And to do the revision, the best way is to solve the GATE previous year question. In this particular session of fluid mechanics, we will be taking important PYQ questions from both mechanical and civil branch. And also we will talk about the concept in detail, so that you will have a complete clarity of the concept and you will have the confidence in those concepts as well. So let's get started here. We'll start with the problem first that came in mechanical GATE 2019 examination. Now we will study first of all the question here and we will understand how to approach such kind of questions. So reading the question is what very important. So they've mentioned two immiscible incompressible viscous fluids having same density but different viscosity like mu2, mu1. And it is contained between two parallel plates. The bottom plate fixed and the top plate is moving with 3 meters per second speed. And there are some assumptions also they have taken, like Newtonian fluid they have mentioned, steady flow, fully developed laminar flow it is there with zero pressure gradient in all the directions. Okay, so the momentum equation simplifies to this one. Mu2 value is twice of that of mu1. So then the velocity at the interface, round off to 1 decimal place, is interface velocity we need to find out. Now very important point here, as they have given pressure gradient is 0 in across all the directions, it means the motion is happening because of the shear provided by the top plate. So it is a shear driven flow. There is no role of pressure gradient, right? So this is a shear driven flow. That is first point we need to understand here, because of the pressure gradient value is 0. Now this momentum equation, what is this momentum equation that we need to understand? Momentum equation is nothing but the Navier-Stokes equation. So that Navier-Stokes equation we need to know. Okay, so Navier-Stokes equation, you should remember this Navier-Stokes equation. This is very important for the GATE examination. Minus del P plus mu del square velocity vector plus rho g, like this. This is what we have as a Navier-Stokes equation. Now it is what we have, they've mentioned in the condition steady flow. Okay, steady flow means there is no change in the velocity with respect to time. Fully developed flow. Fully developed flow means the velocity is not going to change in the x direction. So basically flow is happening along the x direction. So in that x direction there is no change in the velocity. That's why it is called as fully developed flow, where the velocities are not going to change. But the velocity variation will be there in the y direction. So it is a case of one-dimensional steady fully developed flow, right? So what will happen? This value acceleration will be 0, right? Acceleration value will be 0. So you should remember what is this dv by dt. This is the total acceleration. This is the total acceleration, which can be represented like ax I cap, ay j cap and az k cap. So first of all it is a one-dimensional flow. So ay az component will not be there. If I talk about ax component as well, there is no variation of velocity with respect to time. That's why dou u by dou t value will be also 0, right? Now dou u by dou x, it is 0 because there is no change in the velocity along the flow because of the fully developed flow. Dou u by dou y will be there, but v value will be 0. So it is a one-dimensional flow. In this question you should remember it is a one-dimensional flow. What are the assumptions? One-dimensional flow it is there. It is a steady flow, fully developed flow, and zero pressure gradient. Zero pressure gradient. These are the assumptions that they have taken. Because of this assumption, the Navier-Stokes equation will convert into d2u by dy square. So this Navier-Stokes equation is very important that you should remember. Okay. So this total acceleration part. Now if I have to write ax component, so you should remember this ax component, how you will write u dou u by dou x plus v dou u by dou y plus w dou u by dou z plus dou u by dou t. So already a, y and az will be 0. Okay. Now dou u by dou t steady flow, it is 0. Dou u by dou z 0. Dou u by dou y, yes, it is having the value because the velocity is going to change in y direction. But v value is 0 and dou u by dou x 0 because of the fully developed flow. So every component of acceleration is 0 in this particular case. Pressure gradient 0. Now this component. So in this case, del square, how to write del square? What do you mean by this del square operator? You will be writing del square operator like this, dou 2 by dou x square plus dou 2 by dou y square plus dou 2 by dou z square, like this. So here this is the velocity vector ui plus vj plus wk, it would be there. So dou 2 u by dou x square, that is what finally we'll be getting from this main Navier-Stokes equation, and they have given also in the question. So important part is we need to understand the question as well. We cannot directly jump to the solution part. Solution is like one line answer. We can solve this question within one line. But the point is what information they have given, how to correctly interpret those information, that is what very important part. Right. So finally this equation will convert into dou 2 u by dou y square equals to 0, which gives us the linear velocity profile. And I will tell you one more thing. What does it mean, like this equation? d2 u by dy square equals to 0. It means a linear velocity profile. So if you integrate, you will be getting a linear velocity profile. So outcome of this particular momentum equation is what? The linear velocity profile. I hope this basic points everyone is understanding here. Okay, now we'll solve this question. Hardly it will take 1 minute to solve this question, right? But these are like some important information that we need to know. So first of all, this bottom plate velocity is 0. Interface velocity vi we have to calculate, and this is having a velocity 3 meter per second. Right, at the interface the shear stress value will be 0 because the shear will be applied by the top layer above the interface and the bottom layer from the interface. There are two layers, above the interface and below the interface. Both will apply the equal shear force. Shear stresses value will be equal. Shear stress value will be equal at the interface. From where it is coming? The layer above the interface and the layer just below the interface. Both the layers will apply equal value of the shear force, so equal value of shear stress. Shear stress value calculation from the Newton's law of viscosity will be calculating, right? So let us write down this part here. That interface, if I have to represent, this would be the interface. On this interface, there will be a shear stress applied by both the layers, right? Like this. So the shear stresses value will be equal. Okay, shear stress applied by the bottom layer and shear stress applied by the top layer. Now, so you can consider tau 1 and tau 2, both values are equal. So if I consider from the bottom case, so what is the change in the velocity? Vi minus 0. Okay, the fluid they have kept is mu2, so let us write mu2 here. Velocity change is Vi minus 0, and the difference in the gap, or basically the gap difference is 1. So velocity gradient we need to write, change in velocity for a 1 meter distance, right? Similarly here also, viscosity mu1, 3 minus Vi is the velocity change for a gap of 1 meter. Okay, for a distance of 1 meter we can say. Now as in the question they have mentioned, mu2 is twice of mu1, twice of mu1. So Vi minus 0 equals to mu1, 3 Vi. So mu1 will get cancelled out very easily, and Vi answer you will be getting as 1 meter per second. This is what the answer will be getting. So solution is like a one line solution. Within one line we can solve, and hardly it will take 30 seconds to solve this question. But important part is this discussion. This is what very important. The Navier-Stokes equation application. What is the Navier-Stokes equation? And this body force will not come in this horizontal motion. In this horizontal motion, this boundary force, this body force part will not be coming because it is a horizontal motion. So remember this part. It will be coming when it is inclined or vertical. But in case of horizontal motion, this body force, rho g actually is a representation of body force. That will not come into this particular case. That's why we have ignored that part. So this comes 0, this is 0, this is 0, and this one we have ignored. And this is what we are having, only parameter available in the Navier-Stokes equation based on these assumptions. Right. Now, moving to the next problem. Next problem again from Mechanical GATE 2023 related with the fluid statics chapter. And in this particular question, they are asking the moment per unit width about the base, that is this hinge, about this hinge we have to calculate the moment value. Now in such cases always we will prefer the pressure diagram. We have to create the pressure diagram, and through pressure diagram we will get the forces, and then we can easily calculate the moment about that particular hinge. So let us first draw the pressure diagram here itself. Okay. So the pressure diagram will be taking like this. So these are like pressure variations that we are representing here. Like this. These are the pressure variation. Now, closely observe this part. So let me write out the names here so that it will be easy for us to understand the force values. So this A, B, C, and this, let's suppose this point is D. And one more point we will be considering here. This is E. A, B, C, D, E, and this is F. Like this. Clear? This is what the pressure diagram we will be having. Now, we will calculate the forces. Now, what is the concept here? Concept is the volume of the pressure diagram is equals to the hydrostatic force. Okay. So, the concept that we will be writing here, volume of pressure diagram equals to hydrostatic force value. Okay, equals to hydrostatic force. So this is the concept we should remember. Right. Now, we will better take this diagram on the next page. And then we'll do the detailed analysis of the forces part. Right. So one by one all the forces will be writing. First of all, F1. F1 is nothing but the volume of ABC. Volume of ABC is nothing but the half base into height. What is the base? Base will be this BC. Now BC calculation will be what? Rho GH. Density 1000, H will be what? They have given us 1 meter only. Okay. So here we can write here this point. Okay, the BC, the pressure here in this case would be 1000 into G into H, that is 1. Here in this case, it will remain same. Density is what? 1000. So better write 1000 into G into H, that is 1. Now for FE, density becomes 2000. 2000 into G, okay, into G into height, I will be writing 2 here, okay, like this. So this is what the pressure will be having, and this is what the pressure here in this case will be having. So like this we will draw the pressure diagram, right? Now pressure diagram we have drawn. Now we have to calculate the volume of ABC. Volume of ABC means half base into height. Base is BC. BC value is 1000 into G into 1. And what is the height? 1. So that calculation we will do. Okay, so first we will write down all the forces. Volume of BCDE. So in this case it is a rectangle. So rectangle case will be 1000 rho G. This ED multiplied by CD distance. Into CD distance. That CD distance is nothing but 2 only. Okay. So this BC and DE, that is 1000 into G into 1, and this one, that is 2. Now this calculation we will do, and then finally F3. Volume of BFE. Again a triangle, half base into height. Base will be this 2000 into G into, remember this part, that is base, then height will be 2 only. Now this calculation we can easily perform, right? So if I multiply, so G value we have to see, they have given G value 9.8. So that is 1000 into 9.8, it is there, and divided by 2. That is 4900. 4900 Newton it is there, okay. Then 1000 into G, that is 9.8 into 2 they have mentioned, that is 19600. And here it is 2000 into 9.8 into 4, okay. This 2 and 2 will get cancelled out, so better we can cancel out, into simply 2 we can write. Instead of multiplying 4, we can simply write 2. That is coming as 3920. 39200 Newton. Like this we will be getting. So 4900, 19600 it is there, and 39200 it is there. So these are the forces. Now what they are asking, the moment value. To write down the moment value about the hinge, we need the point of applications. Basically the distance of the forces from the hinge. Now one more important concept we have to understand in pressure diagram, as volume of pressure diagram represents the hydrostatic force. The centroid of the volume, centroid of the pressure diagram basically represents the location of the hydrostatic force. Where the hydrostatic force is going to act, it is the centroid point of the pressure diagram. So as this is a triangle ABC, so h by 3 distance, BCD, it is a rectangle, so half of this one. Again BFE is a triangle, h by 3 from the base. Like that we have to write. So if I have to take the moment value, moment about hinge, that will be written as, see, first of all 4900 multiplied by, now this ABC is a triangle, so h by 3, that is 1 by 3 from the BC, but from hinge this distance I need to add, so 1 by 3 plus 2. Then we have BCDE force, that is 19600 multiplied by this CD, half of this one will be 2, half of this one is 2 by 2 actually, that is 1. Then we have 3920 multiplied by, again BFE is a triangle, so h by 3, that is 2 by 3. So you can simply multiply and you will get the answer of this particular question. So the concept that we have to understand is volume of the pressure diagram equals to hydrostatic force, and the point of application of hydrostatic force is nothing but the centroid of the pressure diagram. So you can do the calculation here, you will get the answer very easily, and you will get the answer also finally. So if I do so here, 4900 it will be there, multiplied by this, if I take this one, 1 by 3 it is there and 2 is there. So we will be adding and then we will multiply. Right. So this is coming as 11,433.3. Then we have 196.00. Okay, it will be as it is because the value will be 1. And then we have this one value 392.00 into 2 divided by 3. So 196.00. So this value we will be writing first 2613.33 and 33. So in this one 196.00 plus 114.33.33 it is there. So it is coming around like this. So they have asked the value, they have asked in kilonewton, right? So if I just divide it with 1000, you will be getting as 57.16. 57.16 kilonewton meter, that will be the answer. So again, please focus on the concept, like how you will draw the pressure diagram, how you will mention the pressures here. That is what very important part of the question. Okay. Now, moving to the next problem here. This one, hydrostatic force in the curved surfaces. In the case of hydrostatic forces in the curved surfaces, like how we can solve this particular question. So two important concepts are there: horizontal force and the vertical force calculation. Horizontal force is simply the projection of the curved surface, and in case of vertical forces, you have to consider the weight of the fluid just above the curved surface. So these are the two concepts. Based on that, they have asked a question in civil engineering GATE 2021 examination. So let us solve this question as well. So first of all, you need to understand the water is still here. So till this point, this is the curved surface we will be considering, this area for the water for calculation of the vertical force, and for oil this area we will be considering. Okay, so for oil this particular area we will be considering, and for this water this area we will be considering. Now, so please understand here, like if I have to calculate the horizontal force because of the water, that will be specific weight into projected area into x bar, right? Same formula will be having for the horizontal forces, right? For water also and oil also. So one by one, first water calculation we will be doing. Okay, so they have given simply the oil specific gravity 0.8, weight of the cylinder also they have given, right, 25 kilonewton. So that will be considered while calculating the net force in the vertical direction. In that case it will be considered. And the length 3 meter they have given, diameter is 2 meter, like that. So this is water only, so 10 to the power 3 into G value, that is 9.81 we will be considering. Okay, now projected area, that is projected area will be 2 into 3 into x bar, 1 and plus 1, that is 2, like this. Clear? So just you have to put the values here. Okay, similarly you will calculate the horizontal force because of oil, that is specific weight of oil projected area into x bar, like this. Okay, now so specific weight 0.8 into 10 to the power 3 into G 9.81 into projected area, that will be this distance is what, 1 meter we have, so 1 into 3 into x bar, that x bar will be nothing but 1 by 2. So from here calculations, horizontal force on water, from water and from oil, both you can calculate. Net force will be the difference, because water will be applying like this, oil will be applying like this. So net force will be the difference of both the values in horizontal direction. In vertical case, both the force will get added, water also upside, oil also get upside, and minus the weight of the cylinder, that we need to write down. So while writing the vertical force because of water, that will be simply the weight of the fluid above the curved surface. So whatever the area we will be having, that is semicircle area. For oil case, this is a quarter circle. So semicircle area. So specific weight first of all we'll be writing. To calculate the weight, first specific weight multiplied by the volume. Volume will be this pi r square. Okay. Pi r square. R value they have given us 1 meter. Pi r square by 2 because semicircle area multiplied by the length of the cylinder. Then vertical force because of the oil. Again same thing, specific weight we have to write first for the oil. So specific gravity 0.8 10 to the power 3 into G 9.81 into the quarter circle. Quarter circle means pi r square by 4 into the length 3. So like this you will be getting the answer of vertical as well as the horizontal forces. Horizontal force will be the difference, in the vertical case both will get added. So the ratio they have asked, okay, ratio they have asked the net force of the vertical divided by the net force in the horizontal. So the ratio they have asked like this, vertical net force divided by the horizontal net force. That will be vertical force because of the water, vertical force because of oil minus 25 kilonewton, and here horizontal force because of water minus horizontal force because of oil, like this. So from here you can easily do the calculations. All the values I have substituted. Based on that, if you do all those calculations, you will get the answer here. Okay. So the answer that will be coming in this particular case is approximately 0.37. So the answer that will be coming here is approximately 0.37. So these are like basic calculations that you can easily manage. There will not be any issue. Right. Now moving to the next problem here. This one again from the civil engineering GATE 2019 examination. So two identical pipes they have mentioned here. So having the same length, same diameter and the same roughness it is there. Used to withdraw the water from a reservoir. In first case it is connected in series, in second case it is connected in parallel case. So what we need to do here, we have to find out the ratio of the discharge in the parallel arrangement to the series arrangement. So in such cases, first of all try to understand the question and draw the diagram if it is possible. Okay, because if you draw the diagram it will give you the better clarity about the question. So you can consider there is a reservoir, right? So there is one pipe connected like this and another pipe is connected like this. Pipe 1, pipe 2 in series connection, right? So same length, same diameter, same roughness, everything is same in both the pipes. So that is series connection. In parallel connection, how you will consider? So there is one pipe like this and there is another pipe like this. Pipe 1, pipe 2. Now obviously in this case QP by 2 will be coming. Total discharge is QP, but from the individual pipe QP by 2 will be coming. If I have to see the total discharge coming from the parallel series, parallel case arrangement. In the case of parallel case arrangement, what is the total discharge? QP, but from individual pipe it will be QP by 2. In this case, what is the discharge coming? QS. So what is the ratio they are asking? QP by QS. QP by QS. So what I can do here, directly I will take the head loss here and here equal. Taking the head loss equal, we will get the ratio of QP by QS very easily. So what we will be doing, head loss in series case equals to head loss in parallel case. Head loss in series case will be equals to head loss in parallel case. Now series case, obviously the head loss will get added. If I have to write for one, simply it will get added. So twice I am writing FLQS square divided by 12.1 d to the power 5. So this is the direct formula that we should remember. In this case, how we will write FL? For any pipe I can write, because for both the pipe head loss will remain same. So QP by 2 divided by 12.1 d to the power 5. Now QP by QS we have to find out. So everything is what constant, we can remove the constant part, QP by QS. So 2 square will be 4, 4 into 2, 8 will be there. So QP by QS whole square, and it is 8. So finally QP by QS, if I do, you will get the answer, like under root 8 if you do, it will be coming 2.8. 2.8 is the answer in this particular case, right? So correct up to 2 decimal places to 2.82 you can write. Very, very simple question. So if you are able to understand the diagram, right, the information given, please draw the diagram, and from the diagram you will have much more clarity about the question as well. Okay. Now, next question. This is again very, very important question, because direct application of the Navier-Stokes equation. They are asking the pressure gradient vector. So to calculate that pressure gradient vector, we need to know the Navier-Stokes equation. So first of all, what I will do here, Navier-Stokes equation in the x direction I will write. So Navier-Stokes equation in the x direction. So density it is there, dou u by dou t, acceleration ax will come here, u dou u by dou x, v dou u by dou y, w dou u by dou z, like this it will be there, equals to minus dou p by dou x, mu dou 2 u by dou y square, dou x square it will be there, and then you will be having dou 2 u by dou y square and dou 2 u by dou z square, like this it will be there. This equation will be there. Then this is the body force, rho g x, like this, right? So they have mentioned two-dimensional incompressible frictionless flow field, velocity vector they have given. Okay, so first of all, see the velocity vector they have given, u I cap, instead of u directly I can write here x, but actually that x value is nothing but the u only, minus y j cap. So this x is the value of u and this minus y is the value of v. So ui cap plus v j cap and w k cap we are writing as a velocity vector. So this u value is x, minus y is the value of v. So this thing we should know, right? Now this conditions, all those conditions we need to apply in this particular question. So obviously they have mentioned two-dimensional, it is there, incompressible, frictionless, everything they have mentioned, density of the fluid, if rho is the density of the fluid, expression of the pressure gradient. So two-dimensional flow is there, only x and y, dou p by dou x and dou p by dou y, it is what required, clear? But they have nothing, they have mentioned frictionless, so viscosity value will be what? 0. Frictionless means viscosity values will be 0, we don't need to consider that part. Body force also will not be considering in this case, until unless they have mentioned to consider that body forces, then only we will consider, otherwise we will not consider, right? So incompressible it is there, that it means density is not going to change, right? Now, so understand this part. So what are the values we will be having? U value is x and v value is minus y. This is what they have given. Now, so if you put all those values, time, so if you see the velocity vector, is there any time parameter? No. So this will be 0. This will be 0. Dou u by dou y, is there any y function? No, it is 0. Dou u by dou z? No, it is 0. Okay. So please see, u they have given as only x. So there is no y component, there is no z component. That's why dou u by dou y, dou u by dou z, this term will be 0. Viscosity value, it is 0 here. Okay, we don't need to consider this part. So directly I can write minus dou p by dou x equals to rho u dou u by dou x. What is u? X. Dou u by dou x value will be what? 1. So you will get the answer as dou p by dou x as minus rho x. This is what the value we got finally. This is the value of the dou p by dou x. Now, in a same way, we will apply the Navier-Stokes equation in the y direction. Now, as we all know that viscosity, all those terms are not there. Directly, I can write the simplified form of the Navier-Stokes equation in y direction. So, density will be there, okay, dou v by dou t plus u dou v by dou x, v dou v by dou y plus w dou v by dou z equals to minus dou p by dou y only, because this term and this term we don't need to consider. Now, v value is minus y. Now, minus y it is there. Is there any x and z component? No. So, there is no time component also. So, this term will be 0. So, finally, you will be getting dou p by dou y. Now, what is the v value? Minus y. What is dou v by dou y? Minus 1. Minus 1 and that minus 1 already will get cancelled out. Okay. So, dou p by dou y also you will get it as minus rho into y. Rho into y you will be getting. So, this answer you got it finally. So, just for your clarity, please understand u value is minus y. What is dou v by dou y value? Again minus 1. So, this minus 1 and minus y will get multiplied. So, only y value will be there. Okay. And already minus sign is there. So, that's why dou p by dou y is minus rho y. So, here minus minus gets cancelled out, but already minus sign is there. No? So, that's why dou p by dou y is minus rho y. Both the pressure gradient in xy direction we got it. So, how you will write pressure gradient vector? Okay, see how we will be writing the pressure gradient vector. Dou p by dou x I cap plus dou p by dou y j cap. So, dou p by dou x value is minus rho x. Minus rho y. So, you will be taking minus rho common. So, it will be x I cap plus y j cap. This is what called as the pressure gradient vector we are having. And if you see the options, so if you see the option, this option basically B will be the correct, minus rho x I cap plus y j cap. That is what we got, minus rho x I cap plus y j cap. I hope this is clear. So, Navier-Stokes equation is very important concept for the fluid mechanics in our GATE examination. So, please try to remember that Navier-Stokes equation, and whenever pressure gradient question comes, you should use the Navier-Stokes equation to get the answer. So, I hope the whatever questions we have discussed in this particular session is clear to you, and as well as the concepts that we have discussed here, from the hydrostatic force to the viscosity part to the series and parallel combination and the Navier-Stokes equations as well, right. So, now we will be discussing some more questions in the upcoming sessions for different subjects, right. In the last, I want to just tell you about the test series part, guys. The test series product that IMS GATE Academy has launched, because the test series plays a very important role in the GATE preparation. You should be having a test series and you should practice your revision part, okay, and everything from the test series only, because if you are not following the test series, that means you are not evaluating your performance. This is a very important thing. Test series is a kind of feedback. You have to regularly, on a regular intervals, you have to give the test so that you can improve yourself. You will evaluate yourself, you will understand your weakness and the mistakes that you are doing, and then you will work on it, and so that you will get improved, and then finally in the GATE examination you will score a very good marks. So, in the test series product you will be getting everything which is mentioned here, and apart from that, the test series also contains the chapter, subject and full length subject test. Apart from that, doubt solving portal you will be getting, online doubt discussions you will be getting, PSU mock interview sessions you will be getting, and post GATE guidance program. Everything you will be getting, and the important part is you will be getting the PYQ books, technical books separately you will be getting, and one maths and aptitude separate booklet you will be getting. So, you can offer this test series product, okay. And the live online program for the 26 GATE program we have already started, where you will be having more than 800 hours of session. Apart from that, PYQ books and the 12 one-to-one mentorship sessions in which you can directly connect with the faculty who has taught the subject, and you can discuss your concerns regarding your preparations. And if you are interested, you can directly call on these numbers to book a free counseling session. And in the last, one more thing that I want to tell you regarding the Telegram group that we are having. You can join this Telegram group where you will be getting the daily quizzes. You will be getting daily recruitment notifications. Every important details of YouTube lectures also you will be getting here itself. So you can directly click on this link and you can join the Telegram for most important updates of the GATE examination and also other PSU examinations. I hope you have enjoyed the lecture. Please make sure that in this last month you should focus on the PYQ and revise your subject while solving the PYQ important questions. Thank you so much.